All right, in this lesson, we're going to keep looking at parabolas and some things we can find in vertex form. Just a reminder, standard form looks like this, where you got ax squared plus bx plus c. And then vertex form is the one we looked at in the previous notes, where h and k is our vertex here. Okay, so we're going to start out by graphing out this kind of basic parabola, and then a lot of what we're going to be looking at today will come off of this kind of parent. It's called the parent function because it's the kind of the basic, just plain x squared parabola centered, as you'll see here at 0, 0. So what we're going to do is come up with this graph, and we're just going to go basic here. We're just going to enter in some values for x. So we're just going to pick some here, and I'm going to kind of pick it so 0 ends up in our middle here. So we're going to put those x values in for the function and see what y value comes out. Well, we know this function is just squaring whatever we put in for x. So if we take -3 and square it, -3 times -3 is +9. -2 squared would be 4. -1 times -1 is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. So if we graph out those ordered pairs now over on this graph, 0, 0, 1, 1, 2, 4, 3, 9 would be up here somewhere. -1, 1, we know it's symmetrical, so we should have these symmetrical points here. And our parabola looks like this. So what we're going to be doing when we graph out a lot of these today is they are just transformations, or this graph altered in some way. So we're going to use this one to kind of help us out here when we're graphing these. Okay, so the first one here, or first transformation one, what does this one look like in comparison to our parent function here, x squared? Well, this is the same function squared, except that we got this -3 in here. What does that do? Well, if you recall from the transformations we did in trig and previously in pre-calc, that any number inside the function is going to shift this left or right. And inside the function is always opposite. So if you got minus, usually we would take negative in the left-right direction to mean going left, but because it's opposite, this one's going to get shifted right 3 units. Okay, so it's going to be that same graph that we started with, and I'm just going to kind of sketch that one out here. So remember we had points at 1, 1, 2, 4, 3, 9. So it looks something like this. That's kind of that's our parent function right there. Now if we're going to graph this one, it's that same graph, just 3 units to the right. So if we just move this point over 1, 2, 3 spots right here, the vertex, move it over 3 spots, the other point should also then get shifted over 3 points, or 3 to the right. So 1, 1 was kind of 1, going over 1, up 1, over 2, up 4 was a point, over 3, up 9 was a point. And so if we base those same points off of this new vertex, you get the one we're looking at here. Whoop, kind of missed that point, but same idea. So that would be the graph of this one right there. So if there's a transformation going on, you can get it by basing it off of that parent function, with the new vertex here being at 3, 0 instead of 0, 0. All right, let's try another one. All right, so again, this one, it looks like something's inside the function, so that's going to shift it left or right here. Usually plus would mean to the right, but remember it's inside, so it's going to be opposite, so this is going to be shifted left 4 spots. So if we base it off of our parent one, again, remember parent one looked like this here. So this is our parent function, that's that x squared one. This new graph is going to be the same one, just 4 to the left, 1, 2, 3. So that's going to be here. Now our vertex is at 4, 0. And then we got those same points going on here. So it looks like this. This would be the graph of x squared equals x minus x plus 4 squared. So transformations, you can get the new function fairly quickly by doing some of these. All right, next one. Now we got something going out on outside the function. Remember, outside the function, this is going to shift up or down. And this holds true to what you'd normally think about plus and minus. So negative, because it's minus 2, this one's going to shift it down 2 units. So we're going to take our parent function again, and we're going to shift it down. So our regular x squared graph to look like this. So we had points here. This is that same parent one of x squared. This new one, because we're shifting it down, so you're just going to move it down 2 spots. So here, all those other points, over 1 up 1, over 2 up 4, should still all work off this, over 3 up 9, and looks something like this. So graph of this one would look the same, just shifted down 2 spots. Okay, so this one, pretty similar to our last one. Instead of going down 2, though, this one would then be shifted up 2. And so this one, we just go up 2 from the origin. So now our vertex is at 2, 0, or sorry, 0, 2. And we'd have point over 1 up 1, over 2 up 4. So here and here, and we get that same basic shape. Okay. All right. So next, what we're going to look at, what happens when you start putting numbers in front or being multiplied to your function. So when that happens, what we're going to be looking at is a shift of something that is outside this function is, again, we're going to do something to it up and down. But this is going to kind of make it either kind of wider or narrower. But basically, because it's outside, it's going to stretch this vertically by a factor of 2. So anything outside the function is always going to be vertically, and that's going to make this be a kind of a longer graph here. And it's not going to do anything to our vertex. So our vertex here is still going to be the vertex of x squared, which would be at 0, 0. So let's sketch out that parent function again. So the parent function of x squared, we had point here, 2, it's going to be 4. At 3, it's going to be 9. So here and here. So we'll get that parent one on there just as a reference. This one, again, is going to have a vertex at 0, 0. But now at 1, instead of at going 1 ending up at 1, if we put 1 in here, 1 squared is 1, but then it's going to get times by 2. So instead of being at 1, a height of 1, it's going to be at a height of 2 now. Same with the symmetrical point. If we go over to 2, before we had a point at 4, but if we double 4, now that's going to be at 8. So that point's going to be up here. So this new function, you can see, is going to get stretched or be a little bit narrower because all these points are getting doubled on the y value. So that would be the graph of 2x squared. Okay. This is outside the function 2. This is a half, so now this is going to get kind of, in essence, shrunk, or going to shrink by a factor of half. And it's going to be vertically again, because anything outside the function is vertical. So if we start with our parent function again here, looks like this. So there's our parent function. If this new one, every point's going to be halved. This is still going to have a vertex of 0, 0. So we start at the same point, but now at 1, instead of being at 1, half of 1 is going to be half. So at both -1 and +1, our y value is going to be half of what it was before. Before at 2, our value was 4. Well, half of 4 is now 2. So our y value at 2 and -2 would be 2. At 3, before our value was 9, because 3 squared is 9, now it's going to be half of that. So it's only going to be at 4 and a half here, and so on. So this one's going to look more like this. It's going to be a wider graph there than the one we had before, because everything vertically is only half of what it was before. Okay, next one. Again, this is outside the function, so we got something going on outside. So we have the 2 here is going to do a vertical stretch of 2 here. But then we got something new going on. We also have a negative sign. And when you have a negative, that's going to be a reflection vertically. Because anything outside is going to be vertical in nature. So let's put our parent function on here again. So we got point here, here, here. All right, so we're starting with that same graph again. Looks like this. So that first thing, that 2 is going to double all the points vertically like we had before. So still 0 is going to be 0, but 1 is going to be 2 instead of 1. At 2 before, our point was at 4, but now it's going to be double that, so it's going to be at 8. Okay, so that would be that graph we had before of y equals 2x squared. But we want -2x squared. So our final one now, we want to reflect all these points over vertically. So 0, 0 is going to stay in the same spot, but this one is two units here away from the axis, so that's going to get reflected here. And that point would get reflected there because we're reflecting over the x-axis, basically. The point we had here at 8 would now be at -8. So those points are going to be here and here. So this would be the final graph here. This would be the graph of y equals -2x squared. So when you're doing, if there's a negative, that's going to reflect it. All right, your turn here. See if you can, on this one, come up with the transformations that are happening on here. I'll give you a hint. There's 3 of them. See if you can find them. So pause the video, see if you can write them down. All right, let's see what you had. If you had that, it was shifted to the right 1, up 3, and reflected vertically. You got it here. Those were the things going on. So let's see if we can do that graph here. So first off, let's find the new vertex. So instead of being at 0, 0 here, we're going to change that by going 1 right and up 3. So that would put our new vertex right here at this location at 1, 3. Okay, now let's, even though we still got a reflection going on here, let's sketch this one out. So we'd have a point at over 1, up 1, left 1, up 1, over 2, up 4, over 2, up 4. And that kind of gives us an idea here. Now this isn't our final one, remember. This would be the graph of y equals x minus 1 squared plus 3, but we want that negative now, so let's reflect that over the axis for our final one. So now we're going to do a reflection here and flip this graph over the x-axis, or reflected vertically. So we're going to basically, instead of really reflecting over x-axis, now we're reflecting over the line that would be right here. So all the points are going to get flipped. So that point should stay the same. This point should now move here. This point would move there. Our point we had here would be down 4 now. We'd have a symmetrical point over here. And so the final one here would look like that. So it got reflected vertically there. So that would be our final graph. All right. All right, for this one, see if you can, again, write down all the things that you think are going on this one. So pause the video and see what you get. All right, let's see what you got. This one's, we should have had that. It's going to be left 1, because remember, inside's opposite. This is plus here, so it's going to be left 1. Down 5, because we got minus 5. And then there is a 2 being multiplied out there, so it'd be a vertical stretch of 2. So where's this one going to be? Go do your left 1 and down 5. That's going to put the new vertex right there. So that's where vertex is going to be at -1, -5. And now all our points are going to get doubled. So usually we go over 1, up 1. Now we're going to be going over 1, up 2, because the y value got doubled. Over 1, up 2. Then usually it's over 2, up 4. So that's point of 4 is going to get doubled. So now it'd be up 8. So it'd be there and symmetrical point there. So this graph's going to look something like this. Now, one thing you can do if you want to check some of these is you can graph it out and check some of these points. So I went on the graphing calculator. Remember, hit your y equal button over here, and you can type in this function. I got it typed in here. If you hit graph, you should see a graph that looks something like the one we got here, and looks like we got it pretty good there. If you go to the table by hitting second graph, because it says table above graph, you can see some of the points. There should be a point on this one at 0, -3, and you can see on our graph, yeah, we do have a point at 0, -3. Some other points there, 1, 3 should be a point on here. We do have a point here at 1, 3 right there. So you can see a lot of the points, and you can scroll up and down and see some more of these points here. We should have a point at -2, -3. You can see on our graph, -2, -3, that's the point right there. So yeah, we are checking off a lot of these points in the correct spots. So you can use that to help you too if you get stuck. Okay. The other thing we're going to look at, just again, kind of figuring out what's the vertex. If it's in vertex form, it's really easy because HK is your vertex. So whatever number's there and whatever number's there is your vertex. Now, you got to be careful with the H. Remember, it's whatever number's being subtracted. That number, not with the negative, is your vertex. If you want to find it in standard form, remember we use our little equation here of x equals -b over 2a, and then plug that into the function to figure out your y value. Okay, so in this one, find the vertex of this one. This is in standard form, so the easiest way would be to use our little equation here. X equals opposite of b over 2a. Our b value here is 6. Our a value is 1. That's -6 over 2 or -3. So now to find the y value, plug that value in. This is what we did in our previous notes here. And see what that equals. -3 times -3 is 9. -18 plus 10. Looks like that's going to end up being 1. And so our vertex here is at -3, 1. The next one, write our vertex, write in vertex form this equation. So this again is in standard form. They want it in vertex form. So first thing you'd want to do again, figure out what is the vertex of this, and we do the same little equation here. X equals -b over 2a, and you can solve it that way. You can also use calculator again. So let's try that again just to kind of review how you did that. If you want to find it on the calculator, you can go to your graphing thing again here, type in this equation. -2 You can take a picture or take a peek at the graph. Now this one does extend a little bit beyond, the vertex isn't quite on the screen here. So what I'm going to do is I'm going to hit the zoom button and I'm going to hit number 3, zoom out. So if we zoom out a little bit, we should be able to see the whole thing here. And then what I'm going to do here to get that vertex, that's kind of either one of these two. If you go to second, calculate, on the hitting the trace button, you can use that min and max again to find the vertex. This one's a minimum, so I'm going to select minimum here. You need a point to the left and right of where that minimum is. For this one, rather than guessing, I'm going to use the cursor here. Move that cursor to the left of where that vertex is anywhere, hit enter. Then move the cursor to the right of where that vertex is, pass it, hit enter. Hit enter one final time and it'll tell you where that vertex is. So on this one, it looks like the vertex is at negative 3.5. And the y value there was at negative 14.25. So that's the vertex, and if we want to write this in the vertex form again, the form that, or the kind of the equation we had, a times x minus h squared plus k, where hk is the vertex. A, remember, is the same a value you got here. Looks like our a value is 1, and so the equation would be 1x minus negative 3.5 squared plus negative 14.25. Just some things, remember, you don't have to write this 1 here. Minus and negative is the same as plus. So kind of a nicer way to write this one would be just like this. Plus and negative is the same as minus. So that would be vertex form of this equation. Okay. Next one, write the vertex for this. Well, here it is in vertex form. So if they want you to write the vertex when it's in vertex form, should be a lot easier here. That's your h. That's our h. Whatever that number is, that's being subtracted, and this is our k. So our vertex here would be 1, negative 4. With the k, we do want to include the negative if it is. With the h, you don't. If it's whatever's being subtracted, that would be your h value. So this vertex would be right here. So the next one, same thing. This would be our h, this would be our k. And so in this one, the vertex is at 2, negative 1 would be our vertex here. Okay, find the x-intercepts. Recall when you're doing x-intercepts, that's putting 0 in for y and then solving. And you can do that by factoring, quadratic formula, solving with square roots, whatever's easiest. This one I believe looks like it can be factored. You got 2 factors here. What's going to multiply negative 7 and add to 6? Looks like minus 7 plus 1. And so our two x-intercepts would be at 7 and negative 1. Okay, let's do the same one. Now this one's in vertex form, but same thing. Put 0 in for y and solve for x. This one, I think we can do by just doing some algebra solving here with some square roots. So let's start, we want to solve for x, so let's get everything away from the x. Let's first add 1. Okay, get that 1 to the other side. Okay, now how do we undo something squared? We got to square root it. But remember, it could be plus or minus whatever we're squaring on that side. And so what we got left here on the right side is that we got x minus 2, because the square root and the square basically undo each other. And then here we got square root of 1 is 1, so plus or minus 1. To finish this now, you want to just solve that out and see what you get. If you got something minus 2 equals positive 1 or something minus 2 equals negative 1, what do you get when you solve? So we want to now solve what is by adding 2 to the other side. What do we get? So we got 2 plus or minus 1. So the answers to this one would be 2 plus 1 is 3, 2 minus 1 is 1. So the answers would be 3 and 1. Um, so when you're doing this, see what that gets when you solve for x. All right, so your turn on the last one here. See if you can find the x-intercepts on this one. So again, you want to be putting 0 in for y in solving. So pause it and see what you get. All right, let's see how you did here. If you put 0 in for y, first add 4 over. Then we want to square root to get rid of the square there. So if we square root the right side, all that we're going to have left, because these would cancel out, is x minus 5. On the other side, square root of 4 is 2, so we got positive or negative 2. Then add 5 over to the other side here. And you got 5 plus or minus 2. Well, 5 plus 2 is 7. 5 minus 2 is 3. So those would be the two x-intercepts of this graph. Okay, you're going to now be trying some of these out on the practice sheet.